Okay, in today's class, we are going to just learn about kite. Kite is a quadrilateral in which two pair of adjacent sides are equal. Okay, a quadrilateral with two pair of adjacent equal sides. If you are just saying taking A, B, C, it is a kite. Two pair of adjacent sides, it will be in equal in length. AB is equal to AD or BC is equal to CD. This type of picture is comes under kite. Two pair of adjacent sides, it will be equal in length. The properties of kite is the longer diagonal. Okay, the longer diagonal means here AC is the longer diagonal. Okay, the longer diagonal bisect the other diagonal. So the longer diagonal is dividing the smaller diagonal into two equal parts. That means OB, it will be equal to OD. Second point, okay, the longer diagonal bisect the angle. Okay, the longer diagonals bisect the angle. So dividing into two equal angles. It will divide into two equal angles. Next one is the longer one is perpendicular to the other one. Perpendicular means it will form 90 degree. Okay. And here one more thing is these two opposite angles, it will be equal. Okay. The angle B and D also, it will be equal in a kite. Just make a note. This is not given here. Angle B and D, it will be equal. Okay. Fourth one, you can just take it up. Fourth point, angle B, opposite angle. Okay. Angle B, it will be equal to angle D. A and C are not equal. Only angle B and D, it will be equal. The angles between the unequal sides are equal. Okay, this is the fourth one. You can just note it down, right? So this is the properties of kite. So next, trapezium. Next shape is trapezium. A quadrilateral with at least one pair of opposite sides are parallel. Okay, a quadrilateral with only one pair of opposite sides are parallel is called trapezium. Both pair of opposite sides are parallel is called parallelogram. Okay, both pair of opposite sides are parallel is called parallelogram. Only one pair of opposite sides are parallel is called as trapezium. Okay, so A, B, C is the trapezium I have taken. In case here these two are non-parallel sides. If it's the non-parallel sides are equal in length, that is called as isosceles trapezium. Okay, these two are parallel side. EH and FG are non-parallel side. Like if the non-parallel sides are equal in length, that is called as isosceles trapezium. Okay, in isosceles trapezium, right? So we have two property. One is in the trapezium, sum of two angles on the same side. Okay, angle A plus D, it will be equal to 180 degree, or B plus C, it will be equal to 180 degree. That is the first property. Angles on the same side. Okay, of a trapezium is 180 degree. Second property is about isosceles triangle and isosceles trapezium. The angles opposite to the equal sides are equal. That means the base angles, it will be equal. Angle H equal to angle G. Angle E is equal to angle F. Okay, and if it's an isosceles trapezium, okay, you can just remember that base angles, it will be equal. Base angle, this also base angles are equal. Okay, these are the properties of trapezium. Okay, so make sure that you are clear with all the properties of kite and trapezium. Now this one is, okay, a quadrilateral Venn diagram. Quadrilateral Venn diagram. So quadrilateral means a polygon with four sides. Okay, under the quadrilateral we have all these shapes: parallelogram, rectangle, square, rhombus, kite, and trapezoid or trapezium. We have learned everything. So under the parallelogram, we have rectangle, square, rhombus. Okay, rhombus, square, rectangle, everything is still be called as a parallelogram. Why? Because these shapes are satisfying the property of parallelogram. Okay, square can be considered as a kite. Rhombus also can be considered as a kite. Why? Because square and rhombus will satisfy the property of a kite. Just remember this. Square and rhombus also will be considered as a kite. Okay, rhombus is a kite, but kite is not a rhombus. It will not come opposite. So it may come in this direction. Okay, we can say a square is satisfying the properties of kite. We'll check what are the properties of kite and rhombus. Okay, well, kite is having only less property, right? So in a kite, okay, pair of adjacent sides are equal. In a rhombus also, a pair of adjacent sides are equal. And diagonals, one of the diagonals are perpendicular bisect each other. Here also, the diagonals are perpendicular bisect each other. Okay, so this is having extra property. Okay, here extra property is all the sides must be equal, then it's a rhombus. A rhombus is satisfying all the properties of kite, therefore rhombus is a kite, but kite is not a rhombus. Okay, we have one question in the exercise. That time also I'll just explain. Right, so it is given all shapes in the inner circle also belongs to the outer shape. For example, every square is a rhombus, rectangle, parallelogram, and a quadrilateral. Okay, for example, every square is a rhombus, rectangle, parallelogram, and a quadrilateral. Can you able to understand this?
Yes, sir.
A square is satisfying all the property of rhombus. Okay, and the kite, and the parallelogram, and the rectangle. Okay, so that's why they have given every square is a rhombus, rectangle, parallelogram, and quadrilateral. Okay, fine. Now we'll come to the figure it out 4.3, page number 107. Okay, figure it out 4.3, page number 107. First question, find all the sides, all the angles of the quadrilateral obtained by joining two equilateral triangle with 4 centimeter side. So we have to join two equilateral triangle with 4 centimeter. Okay, so here I have taken, okay, two triangles. So this is one triangle. Okay, so this is one of the triangle. Okay, this one equilateral triangle with 4 centimeter. Another one is SRQ. This is another triangle with 4 centimeter. Both are equilateral triangle. Now we have to measure all the find all the sides and all the angles. So first you can just write all the sides. Okay, sides it will be 4 centimeter. Okay, equilateral triangle this side means so PS is equal to 4, PQ is equal to 4, QR is equal to 4, and SR is equal to 4 centimeter. First you can just write all the sides. Okay, sides of the triangle. Okay, so PS is equal to 4 centimeter. Okay, 4 centimeter. I think you can just write everything is equal, right? So I can just go with all. Okay, PS is equal to PQ is equal to QR is equal to RS is equal to SQ. Okay, all are equal to 4 centimeter. Okay, sides is given. So next we have to go with the angles. Each angles in an equilateral triangle, it will be 60 degree. That's what's given, right? The measure of all angles of an equilateral triangle is 60 degree. Each angle it will be 60 degree. Now this is 60 degree, 60 degree, 60, 60, 60. This also 60 degree. The measure of each angles in an equilateral triangle is 60 degree. Okay, that means angle P is equal to angle R. So P and R are 60 degree. I can just write. So 60 degree. So next we have two angles, angle S, angle S. Okay, so total angle S, you can just write it as 60 plus 60. 60 plus 60 is equal to 120 degree. Next angle Q also 60 plus 60 is equal to 120 degree. Okay, 120 degree. That's it. So we found out all the sides and all the angles. Now second question. Okay, construct a kite whose diagonals are length 6 centimeter and 8 centimeter. So we have to do the construction of kite. Okay, 6 centimeter and 8 centimeter. Okay, I'll just explain the question, then I'll just go with the construction part, right? So for drawing the kite, okay, kite means the diagonal will not be in equal length. Okay, the longer diagonal will divide the shorter one into equal parts. Okay, remember the properties of the kite. And the longer one, it's bisect, perpendicular bisect, so it will form 90 degrees. So angle is 90 degrees given. So the shorter one, we can take it as 6 centimeter. So just draw a line AC for 6 centimeter. Okay, then mark the center. Okay, mark the center. From the center, we have to draw the 90 degree. Okay, from the center, you just draw 90 degree. Okay, and the 90 degree we have to take. So 8 centimeter, we have to draw the diagonal. So 8, we can just split it as 3 centimeter and 5 centimeter. So above, we can just take 3 centimeter and draw the arc. Below, we can just take 5 centimeter and draw the arc. Okay, now we can join A, B, C, D. You'll be getting a required kite. So we have to construct a kite. Okay, we are going to construct a kite with length 6 centimeter and 8 centimeter. Okay, one of the length is given. Okay, that is length. Okay, diagonal. One of the diagonals are given. Okay, so diagonal 1 I am just taking as 6 centimeter, and diagonal 2 we can just take it as D2 is given as 8 centimeter. Okay, first you just draw the shorter one, shorter diagonal, that is for 6 centimeter. Okay, just take scale and measure 6 centimeter. Okay, just draw 6 centimeter. This is my 6 centimeter. So after drawing the line for 6 centimeter, now you just mark the center. Okay, center means it will be 3 centimeter, correct? Mark 3 centimeter as a center. Okay, this is my 3 centimeter. Okay, so mark it for 3 centimeter. This is my 3 centimeter. So we can just name this as A and C. Now this is my A and C. Okay, A and C. I have drawn the line segment. Now from the center, okay, center we can just name it as O. We know that in a kite, the diagonals, okay, the longer one bisect the shorter one at 90 degree, right? So we have to mark 90 degree. Okay, just use your protractor and mark 90 degree. Okay, so 90 degree is coming here for me. Okay, this is my 90 degree. Right, so now join with 90 degree. Okay, so draw the line for 90 degree. Just my 90 degree, just draw the line for 90 degree. This is my 90 degree construction. Okay, this should be 90 degree. It's over. Now we have 8 centimeter. Another diagonal should be 8 centimeter. 8 centimeter, I'm just splitting as 3 centimeter plus 5 centimeter. Either up we can take 5 centimeter or down you can take 5 centimeter. Now first you just take 3 centimeter in your compass. Okay, just take 3 centimeter in your compass. Okay, this is my 3 centimeter. Okay, just take the 3 centimeter and keep the pointer in the center and draw the arc. Yeah, so draw the arc. Okay, so you're going to draw the arc. Up, we are going to draw 3 centimeter line. That's it. Next, we can just name this as D. Okay, I can just name this as D. Now down, we have to draw 5 centimeter. Again, just mark for 5 centimeter. Okay, so you have to take for 5 centimeter line. Just open up to 5 centimeter. Just my 5 centimeter, right? Now lock it. And so from the center, I have to draw 5 centimeter. Okay, down. Okay, so draw a line for 5 centimeter. Okay, this is B. Now I can just join all the points. Okay, join. So we are just joining this. So AD, AB, BC, and CD. This is my required a kite with the given values. Okay, now this should be 3 centimeter, 3 centimeter, and this is 5 centimeter. So total we have 8 centimeter. And here this is how much? So this is 3 centimeter, and this also 3 centimeter. So total we have 6 centimeter. Hope it's clear how we have drawn it. Okay, this is what we have to draw the construction. Okay, here you can just see. Okay, here they have given this line. Okay, this line without compass. If you want to mark 90-degree, we can do it based on this is nothing but a perpendicular bisector. Okay, so we don't need to go with this. We have the protractor. We can just go with the protractor and keep it in the center and mark 90-degree and draw the line. Now, question number 3. Okay, find the remaining angles in the following trapezium. Okay, this is a trapezium, normal trapezium, and here they have mentioned, okay, this line. This line is representing these two sides are equal. In a trapezium, non-parallel sides are equal is called as isosceles trapezium. One is normal trapezium, another one is isosceles trapezium. Okay, we are going to use the trapezium property. Okay, so we can just name this as A. I'm just taking this is A, B, C, and D. Okay, this one I can just give it as P, Q, R, S. Okay, from the first one, I'll just take this. This is first one, and this is second. In the first one, okay, in the diagram one first, we know that in a trapezium, okay, sum of two interior angles on the same side is equal to 180-degree. Okay, angle A plus angle D. Okay, angle A plus D, it will be equal to 180-degree. This is what the property says. Okay, interior angles on the same side is equal to 180-degree. So angle A is given 135. So 135 plus angle D is equal to 180-degree. So angle D is equal to 180 minus 135. Okay, 180 minus 135 is equal to 45-degree. Okay, angle D is equal to 45-degree. First one is over. Next, we have to find out angle C. Now, this is we got it as 45-degree. Next, we have to find out angle C. Angle C also, okay. Interior angles on the same side of a trapezium is 180-degree, right? So, for finding angle C, okay, so we know that angle B plus C, angle B plus C is equal to 180-degree. Okay, angle B is given 105. 105 plus angle C is equal to 180-degree. Okay, angle C is equal to 180 minus 105. Okay, 180 minus 105 is equal to 75-degree. Okay, 75-degree. Angle D is equal to 45, angle C is equal to 75. We got it. Okay, now we'll come to the second one. Okay, second question. Here is given PQRS is an isosceles trapezium. In isosceles trapezium, we know that base angles are equal. This is 100 means this also will be 100. Okay, so I can just take it as, we can just take it as, okay, here PQRS. Okay, PQRS is an isosceles trapezium. Okay, isosceles trapezium. Why? Because two sides are equal. If it's an isosceles trapezium, the base angles are equal. Angle S, it will be equal to angle R is equal to 100-degree. Both are 100-degree. For finding angle P, right? Interior angles on the same side is equal to 180-degree. So we know that angle S plus angle P is equal to 180-degree. Angle S we got it as 100. Okay, 100 plus angle P is equal to 180-degree. Now angle P is equal to 180 minus 100. Okay, that is angle P is equal to 80-degree. Angle P is 80. If its angle P is 80, this also base angle. Q also is equal to 80-degree. Okay, Q also it will be 80-degree base angles. Or you have to use the same. Angle R is 100, we got it. 100 plus Q is equal to 180-degree. So 180 minus 80 is 180 minus 100 is again we will be getting 80-degree. Two ways. Okay, angle P is equal to 80-degree. Therefore, directly I can just write angle Q also 80 degree. Why? Because base angles of isosceles triangle. Base angles are equal. So clear? These two are 100. This also base angle. These two are 80. Okay, this is also 80 and this also 80 degree. Now we'll just moving on to the question number 4. Okay, question number 4. Draw a Venn diagram showing the set of parallelogram, kites, rhombus, rectangle, and square. Then answer the following question. So they asked us to draw the Venn diagram. I have already given the Venn diagram, so just I have taken it. So based on this Venn diagram, we have to answer the following question. First question. Okay, the first one. What is a quadrilateral that is both kite and a parallelogram? Okay, name the quadrilateral is both kite and parallelogram. Okay, only the rhombus is satisfying the both properties of kite and parallelogram. Okay, so the answer is rhombus. Okay, the answer is rhombus. Okay, rhombus is satisfying the both properties of kite as well as parallelogram. Therefore, this is called as, okay, therefore, this is both a kite and parallelogram. Now, the second one, okay, can there be a quadrilateral that is both kite and rectangle? Okay, square is a quadrilateral that is both kite and rectangle. Okay, the parallelogram will not come. Parallelogram angles are not 90 degree, correct? Okay, only in the square only, both. It's satisfying the property of kite as well as rectangle. So the second one, square is a quadrilateral that is both kite and rectangle. Okay, square. Second one is square. Now the third question is every kite is a rhombus? They are asking. Every kite is not a rhombus. No, every kite is not a rhombus. Not. What is the correct relationship between these two types of quadrilateral? So every rhombus is a kite. So you have to write it as every rhombus can be considered as a kite. Okay, the statement is every rhombus is a kite. Why? Because kite is rhombus is satisfying the property of kite, but kite is not satisfying the property of rhombus. Question number 5. If pair PAIR and rods RODS are two rectangles, PR, so it's given like this. So PAIR pair is a rectangle and rods RODS. Okay, rods. This is also rectangle. Rectangle means all the angles it will be 90 degree. So find IOD. IOD. So this angle we have to find. Okay, this angle we have to find. For finding this angle, right? So this is given, only one angle is given. This is 30 degree. So this is 30 meaning angle R is given 30 degree. First you just write given condition. So given angle R is equal to 30 degrees given. Okay. Now, so PAIR is a rectangle, therefore angle I it will be 90 degree. Correct? So angle I it will be 90 degree. So I can just take angle I is equal to 90 degree. So because it's a rectangle. Okay. Now I can just take the triangle ORI. Okay. In this triangle, I can use the angle sum property. I can just find out this angle. Okay. If I find out this angle, we know that. So RS DO. Okay, that is R. We can write it as ODSR. This is also forming a rectangle. ODSR also a rectangle. Okay, that means that the total should be how much? 90 degree. Okay, total is 90 degree. I can find out this angle by using angle sum property. After finding this angle, I can just subtract from 90 degree. I will be getting only this spot O. Okay, so I'm going to use a triangle in a triangle. Okay, in triangle OIR. Okay, in a triangle OIR, angle O plus angle I plus angle R. Sum of three angles is equal to 180 degree. Angle O I have to find out plus angle I is given. Okay, angle I is given as 90 degree. This one I can take it as 90 degree. Plus angle R is given 30 degree is equal to 180 degree. Now 30 plus 90, angle O plus 120 degree is equal to 180 degree. So now angle O alone, angle O is equal to 180 minus 120 is equal to 60 degree. Okay, now angle O is equal to 60 degree. So we can just say RODS, also a rectangle. Okay, here we can just say RODS is also a rectangle. If it's a rectangle means each angle it will be 90 degree. Okay, rectangle, that means ROD. Okay, three angles. ROD, it will be angle ROD. It will be 90 degree. This angle is 90 degree. We have to find out only IOD. Okay, for finding, therefore IOD, it will be angle IOD is equal to 90 minus. So total is 90. 90 minus this angle we found out, that is 60 degree, right? 90 minus 60. 90 minus 60. 90 minus 60 is 30 degree. Okay, so therefore I can just write angle IOD is equal to 30 degree. Now construct a square with diagonal 6 centimeter without using protractor. Okay, here they mention without using protractor. That means we have to, for constructing 90 degree, we should not use protractor. Okay, in this case you have to use only the compass. Okay, so diagonals are given. So in a square, diagonals are in equal length. So first you can draw AC 6 centimeter and take the center. Okay, from the center we have to draw 90 degree. Okay, from the center we have to draw the 90 degree perpendicular bisector. Then we have to take 3 centimeter, draw an arc, 3 centimeter, draw an arc. Then we will be just joining, we will be getting ABCD is a square. Okay, so this also I'll just explain how to draw the perpendicular bisector. Okay, right. So I'll be just showing the construction table. So diagonals of 6 centimeter. Okay, diagonal is given 6 centimeter. In a square, diagonals are in equal length. So diagonal 1 also 6 centimeter, diagonal 2 also it will be in 6 centimeter. First you draw a 6 centimeter. Okay, diagonal. Diagonal 1 for 6 centimeter. Okay, you can just draw the diagonal for 6 centimeter. So draw the diagonal for 6 centimeter. So normally what will you do? So we can just name this as, what name they have given? AC. Okay, BD. Okay, so we can just name that this is A. This is A. This is C. Okay, A and C. Okay, normally what will you do? We'll be just finding the center. From the center, we'll be using the protractor and we'll be marking 90 degree. But here they have given without using the protractor, we have to form 90 degree. Okay. So now for that, what you have to do means I am going to draw the, okay, so perpendicular bisector. Okay, how to draw the perpendicular bisector? Mean the first step, just keep the pointer in A. Okay, take more than off. Off means this is off, approximately. Correct? Just open your compass up to more than off. Clear? Just take more than off in your compass. Either this length, this length, this also we can mark. Okay, just take more than off, approximately. Just take more than off, and so draw an arc up and down. Okay, so we have to draw the arc up and down. So up one line. Okay, then the same down one line. Okay, so down also one line. Okay, so down also you have to draw a line. Okay, up and down. Okay, with the same measurement, keep the pointer in C. Okay, the same measurement, keep the pointer in C. Now you have to draw the line up and down. Okay, up and down you have to draw a line. Okay, down I have drawn. Now I have to do it up. Okay, up and down you have to draw the line with the same measurement. Take more than half in your compass, so draw the arc. where the two arcs are intersecting. Okay, where the two arcs are intersecting, we can just mark this as, this point as, okay, this is B, this is B, and this is C. Okay, now I can just join. Okay, now I can just join. Okay, if I join these 2 points, it will be a perpendicular bisector. It will be 90° exactly. At the same time, it will divide into 2 equal half. Okay, we are just measure and check. This should be correctly is 3 centimeter. This also 3 centimeter. Correct? This is what you have to construct the perpendicular bisector. Okay. Without, we have drawn the perpendicular line. So you can just see exact 90°. Okay. Now what you have to do? This is diagonal one. 6 centimeter we have drawn. Now we can just mark the center as, okay, mark the center as O. From the center O, now you have to take 3 centimeter in your compass. Okay. Just take 3 centimeter in your compass. So take 3 centimeter in compass and so draw an arc. Okay. So 3 centimeter in your compass. Okay. So keep the pointer in O and draw an arc. Okay. So draw an arc. Okay. Here you have to draw an arc. Mm. Okay. Just draw an arc. This is for 3 centimeter. And down also, I have to draw an arc for 3 centimeter. Okay. So draw an arc for 3 centimeter. That's it. Okay. Now if you are just marking this as, so I can just mark this point as, this is B already marked. Now, okay, now this is B point. Okay. Now this one is B. Okay, this is, we can mark it as B. Okay, this is B and this is C. Okay, this point is C. Mark it as, sorry, we already taken A, B, C, D. Okay, this should be D, correct? So this should be D. Now we can just join all the points, right? So join AB and CD and CD and AD. Okay. So now we got A, B, C, D is a record, a square. Okay, A, B, C is a perfect square now. Okay, so without using the protractors, we have drawn the perpendicular bisector. Then balance everything the same, right? That if you are just measuring, this should be 3 centimeter. This also 3 centimeter. And next, this is 3 centimeter. This also 3 centimeter. Okay. So don't take the perpendicular as point B. Okay, this is not point B. Okay, where the arc we are constructing for 3 centimeter, thus you have to take it as okay, point B. Okay, question number 7. Okay, case CASE. CASE is a square. The point UVWX are the midpoint of the side of the square. Okay, they are midpoint. Okay, these are midpoint is given. U V W X. So these are the midpoints of the sides. What type of quadrilateral is UVWX? Okay, UVWX is, what is the name of this quadrilateral? Actually, the answer is UVWX is a square. Okay, so the answer, what type of quadrilateral is this? The answer is a square. Okay, so we have to give the proof. Okay, so answer for A1. So A1 is UVWX is a square. Square means all the sides are equal and all the angles are equal to 90°. So we have to prove that this is a square, means we have to show that all the sides are equal and one of the angle is 90°. If you're proving one of the angle is 90 degree, automatically all the three angles will form an 90 degree. For the first question alone, I'm just going to explain. So for proving this, we have drawn the diagram. Okay, once again, the same diagram we have given the name. Okay, this is angle 1, angle 2, 3, okay, 4. And we know that, okay, this is CASE, case is the square is given. Square means we know that all the angles are 90 degree. Angle C is equal to 90, angle A is equal to 90. We have to prove that, right? I'm going to prove this angle W is 90 degree as well as, okay, all the angles are equal. So all the sides are equal. This side is equal to this side, and these all the sides are equal, and one of the angles are 90 degree. If I prove this condition, we can say that UVWX is a square. Okay, how can I prove it? So we already learned about the congruency of triangle. Okay, we are going to prove the triangles are congruent. Which two triangle? C, okay, I'm going to prove BCU. This triangle is congruent to, okay, so VCU triangle is congruent to UAX. So these two triangles are congruent. If I prove these two triangles are congruent, okay, by the congruence of triangle, corresponding sides and angles, it will be equal. Based on that, I can prove that this is sides are equal and angles are 90 degree. Okay, so let me check first. So I'm going to choose the triangle. Okay, the triangle, which triangle? Okay, CVU. Okay, I'm just choosing the triangle. In triangle CVU. Okay, AXU. Okay, AXU. So I have to prove these two triangles are congruent. If I prove these two triangles are congruent, corresponding sides, it will be equal. Okay, how can I prove these two triangles are congruent? For example, I am just taking this side. Okay, for your example, for your simplification, I have just taken this is the total sides. Sides it will be equal in a square. This is 4, this is 4, and this is 4, and this also 4 side, 4 centimeter. As they given this is the midpoint. So midpoint means this will be 2 centimeter. This also 2 centimeter. This also it will be 2 centimeter. This also will be 2 centimeter. Right? This is the logic. So CV is equal to CU. UA is equal to AX. All the sides are is coming as equal. Okay, here everything is coming as equal. Right? So according to this, we can just say from these two triangle, CV, V is the midpoint, CV is equal to CU. Why? Because they are the midpoint. So I can just write CU is equal to, I am just writing CV is equal to CU. Why? Because V and U are midpoint. And we can just write it as AU. Okay, AU is equal to AX. Now I can just say these two sides are equal. If you are just choosing this triangle, okay, two sides are equal, we can say CVU is an isosceles triangle. Correct? As two sides are equal, we can say this is an isosceles triangle. If it's an isosceles triangle, base angle it will be equal. Okay, if two sides are equal, two angles it will be equal. It's an isosceles triangle. Okay, okay, as they are two sides are equal, I can say a triangle CVU and triangle AXU or isosceles triangle or isosceles triangle. If it's an isosceles triangle, base angle it will be equal. Angle 1 it will be equal to angle 2, and angle 3 also it will be equal to angle 4. Base angles 1 and 2 are base angle, 3 and 4 are base angles. It will be equal. So our aim, we have to prove these two triangles are congruent triangle. Okay, how can I say? So if you are comparing these two, CV is equal to CU. Okay, all the sides are equal. Okay, sides are coming as equal. Okay, side and one angle 90 degree. So I can just say based on these two triangles are congruent based on side angle side property. Okay, I can just write. So based on this, so the triangle CVU. Just recall the congruence of triangle property. Okay, CVU is congruent to triangle AXU based on side angle side rule. Okay, SAS rule, I can say these two triangles are congruent. Okay, if it's congruent means the sides it will be equal, the angles it will be equal. Angle C it will be equal to angle A. Yes, angle V it will be equal to angle X. Angle U it will be equal to angle U. So these two it will be equal. So automatically UV, okay, if you are just taking this side, okay, UV it will be equal to UX. You may think that it's getting confused. Okay, the concept is we know that this is square. We have to give the proof how we are telling this is a square. For that, we are just telling these two triangles are congruent triangle. If these two triangles are congruent, okay, automatically the corresponding sides it will be equal. Okay, VU it will be equal to XU. Two sides are equal. Automatically all the sides it will be equal. Similarly, all the sides it will be equal. And one more thing we have to prove, one of the angle also is 90 degree, we have to prove it. Now we have proven these two triangles are congruent. Therefore, I can say, so UV, right? So VU, or you can just write as VU, it will be equal to XU based on, okay, CPCT, okay, corresponding parts of congruent triangle. I have proven these two sides are equal. Next, I want to prove angle U is 90 degree. If I take this, okay, CUA is a straight line. We know the straight line is forming 90 degree, correct? Okay, so we know that angle 2 plus angle U plus angle 3. It's forming a straight line 180 degree. Okay, that's a straight line. Okay, angle 2 plus 3, angle 2 and 3 are equal. We have proven. Angle 2 and 3 are equal. Why? Because these two triangles are congruent. Okay, as they are congruent, I can just say that angle 2 and 3, okay, it will be equal. Here itself you can just write angle 2, it will be equal to angle 3. This is also based on CPCT, corresponding parts of congruent triangle. So instead of 2 and 3 both are equal means, so we can just compare these two. Angle 2 plus angle U plus, instead of 3 I can write it as angle 2 is equal to 180 degree. Angle 2 plus 2, that is 2 times angle 2, okay, plus angle U is equal to 180 degree 2. Okay, here we have to get the value for angle 2. How to get the angle 2 means just take the triangle, and this is an isosceles triangle. We'll find out the angle of 2. Okay, what is the angle for 2? Then we'll just substitute here. Okay, so I'm just doing in this side for finding the angle. For finding angle 2, okay, for finding angle 2, I'm just choosing this triangle CVW. So choose the triangle CVW. It's an isosceles triangle. Isosceles triangle base angles it will be equal. Use the angle sum property. Angle 1 plus angle 2 plus angle C is equal to 180 degree. Correct? Angle 1 and 2 are equal. Angle 1 and 2 are equal. So here I have to find out angle 2. I'm just writing angle 1 as angle 2 plus angle 2 plus angle C. Okay, angle C is given, that is 90 degree. Right? Angle C is 90 degree. I can just take it up. This is 90 degree is equal to 180. Angle 2 plus 2 is 2 times angle 2. is equal to, take this 90 to this side, 180 minus 90. Okay, 2 times angle 2 is equal to 180 minus 90 is 90. Now angle 2 alone, okay, 90 by 45. So 90 by 2. If you are just taking this 2 to this side, so it will become multiplication, will become division. Okay, so 2 will be getting 45. So angle 2 is equal to 45. Okay, angle 2 is equal to 45. So in the place I can just write, so 2 times, okay, angle 2 is 45 degree, okay, plus angle u is equal to 180 degree. So 245 is a 90 plus angle u is equal to 180 degree. Angle u is equal to 180 minus 90. So 180 minus 90 is equal to 90 degree. Okay, so we have proven, okay, the sides, corresponding sides are equal and one of the angle is 90 degree. Therefore, according to the property of square, okay, all the sides it will be equal and all the angles it will be equal. Therefore, we can just say that, okay, so therefore I can just say that UVWX is a square. Okay, once again, just quickly I'll just explain the concept. Okay, so by seeing the diagram, we can just easily identify this is a square, correct? So for giving the proof, just take the two triangle, okay, this triangle CUV triangle and AXU triangle. Just choose these two triangles and prove these two triangles are congruent. If the two triangles are congruent, corresponding angles and corresponding sides, it will be equal. Okay, we have proven sides are equal and you have to prove one of the angles are 90 degree. For proving one of the angles are 90 degree, okay, based on isosceles triangle property, you just find out the angle 2. Angle 2 we are getting as 45. Angle 2 and 3 are, it will be equal based on congruency of triangle. So take this as a straight line. Okay, sum of these three angles, it will form 180 degree. Angle 2, angle 3 are equal, 45 and 45. So 45 plus 45 is 90. 180 minus 90 is 90. So this we are getting as 90 degree. Therefore, UVWX is a square. Okay, the same process we have to do it for one more question also. Okay, this I am not doing it. Okay, I am just giving the construction alone. They ask us to find another way of constructing a square within the square. Okay, such that the vertices of inner square lie on the side of the outer square as shown in the figure B. Okay, here also I have given all the marking. Okay, the same wise you have to prove these two triangles are congruent and one of the angle 4 is equal to 90 degree. Okay, this you can just try by yourself. So quickly I'll just go to the next question, question number 8. Okay, if a quadrilateral has 4 equal sides and one angle of 90 degree, will it be a square? If a quadrilateral has 4 equal sides and one angle is 90 degree, it will be a square. Okay, if one angle is 90 degree, automatically all the angles it will become 90 degree. This is 90 mean this should be 90. This is 90, this is 90. That is only possible. Okay, now I'll be just showing the solution here. Okay, the quadrilateral has all the sides are equal and all the angles are 90 degree. Right angle is a square. They ask us to construct, okay, construct and measure. Okay, so we can just construct a square. I have taken 5 centimeter, okay, as the line segment. From P you draw, okay, 90 degree. Just take 5 centimeter in your compass, okay, draw an arc. From Q just mark 90 degree perpendicular line and just take 5 centimeter, draw an arc. Okay, now we can just join, okay, S and R, so you'll be getting a square. There's a construction part, I can do it. Next question number 9. Okay, what type of quadrilateral is one in which opposite sides are equal? Okay, a quadrilateral in which opposite sides are equal. What is the name of the quadrilateral? So the answer will be a parallelogram. Okay, so a type of quadrilateral in which the opposite sides are equal is called as a parallelogram. Okay, so we have to draw the diagonal and check for congruence triangle. So we have to give the proof also. Okay, so I'll be just showing the answer first, then we'll give the proof. Okay, a quadrilateral in which the opposite sides are equal is called as parallelogram. Okay, so how will you prove this is a parallelogram? So we have to prove this ABCD is a parallelogram. Parallelogram means we have to prove that opposite sides are parallel. They have given equal. Now I have to prove opposite sides are parallel. If I prove that's a parallelogram, I can say. For this, I have just taken angle 1, 2, 3, 4. Okay. If I prove these two triangles are congruent, okay, they have given opposite sides are equal. That means this side is equal to this one, and these two sides are equal. Side, okay, two sides are equal. I have proven, and this is AC is common for both the triangle, right? If I choose the triangle ACD, okay, ACD triangle and ACB triangle. So two sides, and this is the common side, right? For both the triangle, this is the common side. So therefore, based on triple S, side property, side rule, I can say these two triangles are congruent. If these two triangles are congruent, so corresponding angles, it will be equal. Okay, angle 3, it will be equal to angle 1, angle 2, 1, 4 are equal. Next, I am just considering AC is the transversal line. If AC is the transversal line, we have proven alternative interior angles are equal. Okay, therefore, the line DC should be parallel to AB. That is a transversal line property. If alternative angles are equal, the two lines are parallel. So I have proven DC is parallel to AB. The same as AD is parallel to CB. So both pair of opposite sides are parallel. Therefore, this is called as, okay, parallelogram. Okay, I'm just showing the answers here. First, we are just taking the triangle ADC triangle and CBA triangle. We are proving these two triangles are congruent based on SSS, okay, triple S concurrency. Okay, based on SSS condition, we can just say these two triangles are congruent. Triangle ADC is congruent to triangle CBA. If these two are equal, corresponding sides and corresponding angles, it will be equal. Angle 1, it will be corresponding to angle 3. Okay, angle 1 and 3 are equal, 2 and 4 are equal. If you are considering AC is a transversal, corresponding angles are equal. Therefore, these two lines are parallel. Okay, the line AD and BC also parallel. So, by the definition of quadrilateral, okay, ABCD is a parallelogram. We are just giving the proof. ABCD is a parallelogram. Right. So now, question number 10. So, will the sum of the angles in a quadrilateral such as the following one is also a 360 degree? Actually, this is also quadrilateral because it's having four sides. 1, 2, 3, 4 sides. This is also quadrilateral. We have to prove this quadrilaterals also having 360 degree as the angle sum property. Okay, so I have to prove this angle is having, okay, 360 degree while adding all the interior angles. Okay, for doing this, I'm just doing the construction. I'll just draw, I'm just joining the point. Okay, I'll just join. So B and D. Okay, I'm just joining B and D. So I'm just naming the angle as this is 1. Okay, angle 1. Okay, 2, 3, 4, 5, 6. Okay, while adding all the angles, right, so I should get 360 degree. Okay, 360 degree we have to prove it. So we first you just consider the triangle, two triangles. Okay. So triangle ADB is one triangle and triangle CDB is one triangle. Okay. So we are just going to use the angle sum property. Okay. So in triangle, I'm just going with the in triangle. In triangle ABD, use the angle sum property. Angle 1 plus angle 2 plus angle 3 is equal to 180 degree. Okay, we'll be getting 180 degree. Okay, this is 180 degree. The same is angle 5 plus 4 plus 5 plus 6. Hmm? The same is in triangle BCD. Okay, triangle BCD. The same is, okay, BCD angle 4 plus angle 5 plus angle 6 is equal to 180 degree. Okay, this is I'm just taking first, this is second equation. Now I am going to add both the equation. Okay, add 1 and 2. I'm just going to add both the both angles. So I'm just going to add equation number 1 and equation number 2. Okay, while adding, just add angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 in left hand side. In right hand side, 180 plus 180. Hmm? Now, angle 1 plus angle 2 and 6, we can just combine. Okay, angle 2 and 6, I can combine. We'll be getting angle D. The same as angle 3 and 4, I can combine. Okay, angle 1 plus angle 2 plus 6, if you are combining 2 plus 6, we are getting angle D. Okay, angle D I am getting. Plus the same as angle 3 and 4, if I add, I'll be getting angle B. Plus angle 5. Okay, angle 5 is equal to 180 plus 180 is 360. Okay, angle 1, I can just write it as angle A. Okay, therefore, angle 1 representing angle A. Okay, that is angle A. So, plus angle D plus angle B plus instead of 5, I can write angle C is equal to 360 degree. So, write it in order. Angle A plus angle B plus angle C plus angle D is equal to 180 degree. Sum of 4 angles of a quadrilateral is, okay, 360 degree. Okay, this is nothing but angle sum property of quadrilateral. Okay, so they ask us to prove this is coming as 360 degree. So we have given the proof. Correct. We just made into two triangles and we have used the angle sum property of triangle. We are getting angle sum property of quadrilateral. Now the last question. Okay, this is true or false. Okay, true or false. First one, state whether the following statement are true or false. Okay, justify your answer. A quadrilateral whose diagonals are equal and bisect each other must be a square. False. Okay, answer is false. Because in a square, diagonals are equal and perpendicular bisect each other. That should form 90 degree. That is a property. Okay. They didn't mention bisect each other at 90 degree. Then it's a square. Okay. Here this is false. A quadrilateral having three right angles. Three right angles means automatically fourth also it will be right angle. Okay. They didn't mention anything about sides. They have given only the angles are equal. Angles are equal means, right, that must be a rectangle. So actually the answer is true. Okay. Third question. A quadrilateral whose diagonals bisect each other must be a parallelogram. A quadrilateral whose diagonal bisect each other must be a parallelogram. That is true. Okay, true. Why? Because parallelogram diagonals are bisect each other. Okay, true. Next, quadrilateral whose diagonals are perpendicular to each other must be a rhombus. It can be a square also, right? In a square and rhombus, the diagonals are perpendicular. Can what about kite? Kite also perpendicular, correct? In kite also we have a perpendicular. So they are asking only that must be a rhombus. So actually this is false. So next one, a quadrilateral in which the opposite angles are equal must be a parallelogram. Whether square, rhombus, rectangle are called as a parallelogram. Yes, right. Then it's a true. Okay, rhombus, square, rectangle. These are all special parallelogram. Therefore, this is true. Okay, a quadrilateral in which all the angles are equal is rectangle. A quadrilateral in which all the angles are equal is a rectangle. So answer is true. Okay, isosceles trapezium are not parallelogram. What is the property of isosceles trapezium? Base angles are equal, but in a parallelogram, opposite angles are equal, right? Therefore, okay, isosceles trapezium or parallelogram is given, that is false, because in a parallelogram, opposite angles are equal, but in isosceles trapezium, base angles are equal. Thank you for watching. Kindly like, subscribe and share. Thank you.